Alrighty, everybody. So what we're going to do hit up here is the law of sines part 1. So these are all the topics that are going to be covered in the lesson, but of course I'm going to break the video down into smaller parts. So in this one, this video, we are only going to cover the first and the second bullet point. I'm going to talk about what an oblique triangle is, and I'm going to tell you how we are deriving the law of sines. We're also going to take a trip down memory lane right here. So remember, if I give you a right triangle, there are a couple ways that we can find missing sides, right? So if you'll notice on your notes, there are 3 different triangles. We're going to do this 3 different ways. Each of them gives us a little different look at a right triangle. This one says, hey, this leg is 3, this leg is 4. Please find the hypotenuse. When we know 2 sides of a right triangle and are looking for the 3rd side, we can always use the Pythagorean theorem. So for this triangle, we are going to use the Pythagorean theorem. Why? I know 2 sides and I want to find the 3rd one. The Pythagorean theorem says c squared equals a squared plus b squared. These are lowercase letters because, as we're going to see, and I'm going to try to drill home again for these videos, is lowercase letters always mean side lengths. So c stands for the side length of the hypotenuse. That's x. We're going to square it. And then a and b are the other 2 sides. I don't care which side is a, and I don't care which side is b. I said b instead of 4. Goodness. I do care that it's 4 instead of a b, but I don't care which one is 3 and which one is 4. So let's go ahead and square these and then add them together. 9 plus 16 is 25. Get x by itself by taking the square root of both sides, and we find out the hypotenuse of this triangle is 5. Which of course it is, because this is a 3, 4, 5 right triangle. Boom. Sometimes though, I'm not going to give you 2 sides. I'll give you 1 side, and sorry about that. I'll give you 1 side, I'll ask for a side, and I'll give you an angle. Well, notice this angle right here is a 30-degree angle. This makes this a special triangle. We have 2 special triangles. We have the 30-degree, 60-degree, 90-degree special triangles, and we have the 45, 45, 90 special triangle. So looking at this one, I'm like, hey, this is 30. So there's my 30. There's my 90. How do I know this one is 60? Well, because all 3 angles inside any triangle have to add up to 180. So 60 plus 30 is 90, 90 plus 90 is 180. There we go. Now, because this is a special triangle, all my sides have a special relationship. Always across from the 30, we call that M. Across from the right angle, that is 2M in a 30, 60, 90. And across from the 60, we say M radical 3. Remember that? Trip down memory lane. So let's take the side that has a number, 4. 4 and 2m are the same value. So we can say 2m equals 4. Divide both sides by 2, and we find out m equals 2. That means in every side, m can be replaced with the number 2. Well, what side do we want to replace it with? Well, we want to find x. And x is m radical 3. They're the same side. So x equals 2 radical 3. Done. And then our last look at our triangles, it gives us 1 side asking for a side, and there's an angle that's not special. If we've got angles that aren't special, we're just going to jump right into our trig ratios. Our trig ratios are sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. So how do we know which sides we have? So glad you asked. First thing I'm going to do is I'm going to come out from that right angle. Across from that right angle is always the hypotenuse. Draw an arc through our acute angle. That arc always hits the adjacent side and the hypotenuse. And then my leftover side is the opposite side. So now we need to figure out, are we going to use sine, cosine, or tangent to find the value of x? Well, x is opposite, 7 is a hypotenuse, so which trig function has both opposite and hypotenuse? Sine. So we're going to say the sine of our angle, the sine of 43 degrees, equals opposite over hypotenuse. Since the right side is a fraction, I'm going to go ahead and I'm going to solve for x by cross multiplying. Remember, if the one side doesn't have a bottom, we know it to be 1. So I'm going to do x times 1 is x. 7 times sine 43 is 7 times sine 43. Now that is an exact answer. That answer is exactly correct, but it doesn't help us a lot. So I'm going to bang this into my calculator, making sure we are in degrees, and I'm going to come up with a decimal answer rounded to 4 decimal places. There we go. Alrighty. But what if we don't have a right angle? I know you're asking, how do we know this isn't a right angle? How is that secretly not 90? We don't know what it is. And I would say you're right, but I would like to remind you that all angles in any triangle have to add up to 180. I said it before, but I didn't write it down, so let's write it down. Oh no, let's not use x, because x is a side. No, no, no. X is already being used. Pay attention. So let's call it theta. So theta plus 120 equals 180. That means my missing angle has to be 60 degrees. Boom. And this triangle is an oblique triangle. We call it oblique because there are no right angles. Because there are no right angles, we can't use sine, cosine, or tangent in the conventional sense. So we're going to come up with a new rule, and that new rule is going to be called the law of sines. For us to use the law of sines, though, I'm going to need a triangle that gives us sides and angles that are in these orders. We got to do this one, this one, this one, and this one. We're going to learn about this one later. Side-side angle will come later. So side angle, angle means we're going to have a triangle. They're going to give us a side length, and then they're going to give us 2 angles that go with that side length. So you can see I have a side, an angle, and an angle, or an angle, angle, and a side. We could also do 2 angles and the side between those 2 angles. Remember, uppercase letters mean angles, lowercase letter means side lengths. I said we would do case number 2 later. Case number 3, side angle side, means I'm going to give you 2 angles and the angle between 2 sides and the angle between those 2 sides. 2 lowercase letters, 1 uppercase letter, because the uppercase letter is an angle. And then our last case says, hey, what if I just gave you the 3 side lengths, A, B, and C? Could we still do law of sines? And that answer is yes. Yes, we could. Well, you know, what are the law of sines? I'm going to show you what it is, and then I'm going to show you how we get it. Here's the law of sines. So I can take the sine of an angle over the side opposite equals the sine of an angle over the side opposite equals the sine of another angle equals this over the side opposite. So how do we ever figure that out? Well, if you take any triangle, I don't care what it is, and inside that triangle we're going to draw a height. You can see that we've got 2 triangles. I've got this triangle over here in yellow, and I've got this triangle right here in blue. So I've got a blue triangle, and I've got a yellow triangle. That yellow triangle is named ABD. Well, let's look at angle A and see if I can make an equation with the height in C. This is how they actually derived the law of sines. They said the sine of angle A equals the length of the height over the length of the hypotenuse on the left, because if that's a right angle, this side is also a right angle. Now, just for fun, let's get h by itself, and you're going to see why I'm going to do it here in a minute. So h times 1 is h. C times the sine of A is C times sine A. Well, let's look at the blue triangle. The blue triangle is called CBD. Well, let's do sine with angle C now. So the sine of angle C, again, equals opposite over hypotenuse. Let's get h by itself. Do a little cross multiplying. H times 1 is h. A times sine C. Well, did you notice I've got a yellow H and I've got a blue H? Because they are both H's, that means the yellow H has to equal the blue H because they're both H. Well, instead of saying H, let's say what H equals. That was a mouthful. So instead of saying yellow H, I'm going to say C sine A equals blue H, which is A times sine C. Now I'm going to divide by the lowercase letters to get the sign, to get all the same letters on the same side. So I'm going to have sine of capital A over lowercase a equals the sine of capital C over lowercase c. That is how they figured out the law of sines. Kind of cool. And I already showed you what the law of sines says. Please notice we're mostly going to label our triangles A, B, and C, where capital A, capital B, and capital C always refer to angles, and little a, little b, little c refer to the sides opposite that angle. Little a is opposite angle A. Little b is opposite angle B. Little c is opposite angle C. Now this is one way to write the law of sines. You can also do the reciprocal of every one. You can flip every one of them over, and it's going to be the same exact law. C over sine C. Boom. Alrighty, so this is where we're going to put a stop to this video. Of course, if you have any questions, you're going to see me in class. Make sure you ask, and I will see you when I see you.